Anyone have any questions? All right, everybody doing okay? All right, we started talking about decision making, chapter 4 on Wednesday last week, and we did example. We created example computing basically averages of 3 test scores that the user enter. And let me go and open one of the example that we did. We said that basically when you write your programs, you can have different kind of structures. And we said that what we did in chapter 3, we execute the statement one after another. These are called form what we call sequential structure. And that then we describe in chapter 4 that you can execute statement conditionally to create what we call selection structure. So in this example, you have basically 2 test scores for a student, and you enter numbers and you compute the average. But what's different than chapter 3 is, in addition to computing the average, which you can do is what you learned from chapter 3, you need also to compute the letter grade, which you have to make decision making, because the letter grade is not going to be based only on the, it's not going to be the same for all the students. It's going to be based on the average. So depending on the average, the student can get an A or a B or a C or a D or an F. So it can be different things. So this is an example of a selection structure where you have to make decisions. All right, and we talk about that, and we give example about how you do one-way selection, how you do two-way selection, etc. And this is an example of how to do multi-way selection. You can use a select case statement based on the average. If it is less than 60, you can determine it's an F. If it is between 60 and 69, it's a D. 70, 79 is a C. 80, 89 is a B. Otherwise, if it is greater than 89, it's an A. So we can do something like that. This is one way to do selection structure. We talk about other ones. Let me go ahead and open the other example we did. And we talk about this is another way you can do multi-way selection, and we're gonna cover it on the PowerPoint presentation today. Usually you would use an if statement like this one would show. All right. This is another way you can do multi-way selection, which is, you know, sometimes you have to use that. Is you can use an if statement. Say if the average is less than 60, right? If it is less than 60, you can set the grade to be an F. Otherwise, okay, this is the else if. If it is not less than 60, it means the opposite condition is true, right? So if average is not less than 60, the opposite of that, average is greater or equal to 60. So if it's greater or equal to 60 and the average is less than 70, this means between 60 and 70, the grade will be D, right? Else, if you get to the else if clause, it means that the previous condition is false. That means DBL average is not less than 70. And not less than 70 mean greater or equal to 70. So average greater or equal to 70 and average less than 80 give you grade of C, right? Else if, that mean again, the previous condition is false, meaning DBL average greater or equal to 80 and less than 90, this will give you a B. Else, it means one thing, that the average is greater or equal to 90, because the previous condition was less than 90, and the grade will be A. Right, so this was an example of we do multi-way selection, all right? But we talk also about one-way selection, right? We talk about doing decision where you either do one thing or another. And this was this first example that we did. And this is going to give you basically based on the average, is going to say either you did a good job or is not going to say anything, right? This is one-way selection. Let me go ahead and open the application in here. So in here we have just a text box or a message in the form, okay? And basically what this does is check the average, right? If the average is greater or equal to 90, it's gonna say good work, right? Otherwise not gonna say anything. This is an example of one-way selection, all right? So you do one-way selection using the if then statement, all right? While you do multi-way selection using the if, else if statement. There's another one is to do two-way selection. You do an if and the else only. This will be two-way selection. So this is basically the idea of what we learn in chapter 4 through the example that we did on Wednesday. But let's go ahead and cover that in the PowerPoint presentation. Right. So we talk about one-way selection, right? Right. One-way selection, you do it using the if then statement. Yeah. Right. So the if then statement give you one-way selection. The syntax is you do if the expression. If the expression is true, you do the statement. Else you don't do anything. All right. So we covered that on Wednesday. And the condition, the expression that you use to test, use a relational operator. Sometimes we call them comparison operator, and these are, you check two values. If one value, the left-hand value is greater than the right-hand value, or if it is less than, or if it is equal, or if it is not equal, you use these two symbols, less than, greater, no spaces between them, or if it is greater or equal, or if it is less or equal. So you use that in an expression. And whenever you use these expressions, it gives you one or two things. Either the expression will be true or it will be false, right? So here's an example, right? Either the length is greater than the width or it is not, either true or false. Either the size is less or equal to 10 or it is not, either it's true or false, right? These we call them relational operator. So they can generate one or two value, true value or a false value, right? It's not like in English, sometimes you may not understand the meaning, what it means exactly. So you may have a gray area. In programming, it's very precise, either it's true or false. Here's an example. This one, you check if the sales amount is greater than 50,000. If it's greater than 50,000, you say you earned a bonus, right? So you can put one statement only between the if statement and the end if statement. So you do one thing if this condition is true. But if you like, you can do multiple statements. In this example, you check if the sales is more than 50,000. If it is more than 50,000, then you do three things. You display the message, you earn the bonus on a message box, and you set the commission rate to 12%. And you increase, you give them a bonus day, 1 day off, all right? So you do three things in here if this condition is more than 50,000. If it is not, you don't do anything, right? So this, again, one-way selection. You use the if and if statement. There are some rules, of course. The if and then must be on the same line, right? And the end if should be on the same line, also on one line by itself. So this is the rule. So in here, if you look in here, the if statement, keyword, and the then keyword are on the same line, and the end if is on a line by itself. Okay. Good programming style, we talk about them. We said that you should always indent code to make it easy to read. So if I look in the code in here, you would see that in the if statement where you set the letter grade, the code is indented. And this is essential, very important, because it allows you to see each decision that you have in here, you have 5 different outcomes, right? You can see them because they are indented. If you don't indent them, you're not going to see them. So this spacing between in here, the spacing that you're adding is essential for readability. If you put everything, imagine if everything is adjusted to the left column, then you won't be able to understand the code. This is called a programming style, and it is always a good idea to do indentation to make your code readable, so you can see the different structures. So Visual Basic does not require this, but Visual Studio does the indentation for you automatically. So this is a nice thing about that. When you have arithmetic operator mixed with a relational operator, this is a relational operator greater than, and you have two arithmetic operators, the plus and the minus. You do first arithmetic operator, evaluate them first, then do the comparison operator. So first you evaluate int x plus int y, then you evaluate int a minus int b, then the resulting value are compared to see if the left-hand value is greater than the right-hand value, right? So this is the order of it. So always you do the arithmetic operator before the relational operator. Now, if you want to make that clear, and programmers like to do that, they enclose that in parentheses to indicate that you want to do the addition and the subtraction first. So you enclose them in parentheses, all right? So you could have done it like the first one. You don't need parentheses because arithmetic operator are evaluated before the operator, but this will make it clearer that that's what you want. And you can use a function as an argument, right? So in other words, if you want to compare in here the value that the user enter in the text box, right? Remember what the user enter is text, not numbers. You convert this first to an integer using the CINT function, and then the resulting number or resulting integer get compared with an integer 100. So to do the comparison. In this case, you have to do CINT to do that, because if you don't, then you have in here the left-hand side is a text, while the right-hand side is a number, and you're comparing apple and oranges. So they have to be of the same type. And if you like, you can use declare Boolean variable. We talk about different data type in chapter 3, but we didn't get to use a Boolean variable. So in chapter 4 and 5, we can start using Boolean variable. A Boolean variable is a variable that can store either a true or false value. Integer can store whole numbers, floating point like double can store fractional numbers, but Boolean variable can store only one or two things, either true or false. That's all what they can store, right? And the nice thing about using Boolean variable, it make it more like English-like when you write code that have Boolean variable, right? For example, instead of saying if DBL sales are greater than 50,000, you can just simply if BL and quota met, right? And this would have the BL and quota it's a Boolean variable that would have in it will be assigned the relationship, maybe DBL sales greater than 50,000. So you can do something like this. Let me turn the projector on. All right, and I want to go ahead and start the visualizer. So we know that we can do something. So we can do, maybe we can do an if statement and say if DBL sales greater than 50,000, then we can do some stuff. So you can do that. You can always do that, right? But if you like, you can define in here, use a dim statement, and define in here BLN quota met as Boolean, which is a Boolean variable that can store either true and false. And then you can do something like BLN quota met, and you can set it equal to DBL sales greater than 50,000, right? So you can assign it this value, right? You can put it in parentheses if you like, right? And this is going to have one or two things. It's going to have either true or false. If the sales is more than 50,000, it's going to be true. If the sales is less than 50,000, that's or equal to 50,000, it's going to be false. And then based on that, you can just use it in an if statement. Okay, and you can say if, and instead of having to say DBL sales less greater than 50,000, you say if BL and quota met. Which make it more like English-like. Right. So sometimes you may want to use Boolean variable to make it easier to read. So these are equivalent, right? But this is more like English-like. Did I meet my quota? Right. Then you do something. If not, better than saying DL sales greater than 50,000. Right. So you can do that. Right. So so this is called the Boolean variable. Sometimes we call them flags, like more like a flag. That means either it's true or false. If it's true, that means the flag is on, you can go. If it is false, that means it's not on, you cannot go, or something like that. So we call them flags sometimes. Right. So in here, so these are Boolean variables, and we're gonna be using them in chapter 4 and 5. Right. So one-way selection you're implementing using the if then statement. If you have two possible outcomes, then you can use a if then else statement. If then else statement give you two possible outcomes. Right. For example, this is a syntax: is you check an expression. If the expression is true, then you perform the statement following between the then and the else. It's called the then clause. You perform this statement, right? If the expression is false, on the other hand, you perform the statement between the else and if. These are called the else clause. You do the else clause, right? So in here, this statement have two clauses: the if, the then clause, and the else clause. The then clause you execute if the expression is true, and the else clause you execute if the expression is false, right? So it's basically based on the value of the expression, right? If the expression is true, you execute the statement between the if then and the else. If the expression is false, you execute the statement between the else and if. Right, here's an example in here. You check if the temperature is less than 40. If it is less than 40, then you display the message it's cold. If it is not less than 40, then you say the message nice weather we're having. Okay. And this is the if statement in here, right? So you check the condition, temperature less than 40. If it is true, you display little cold. If it is false, this is then clause, right? If it is false, you do the else clause, which is display the message nice weather we're having. So you get two possible outcomes with a two-way selection, right? So the if then else has two choices. The condition will either be true or false. So either the then clause or the else clause will be executed. There are two mutually exclusive choices. The important thing, these are mutually exclusive, right? You can either have the else clause or the then clause. You cannot have both of them. So it's mutually exclusive. One only can be true. Now you can do multi-way selection using if then else if. If then else if allow you to have multiple outcomes, like determining the letter grade. So in this case, you can have 5 outcomes. You can have grade of A, B, C, D, or F. So they have 5 different outcomes. So in this case, you cannot use the if then else. You have to use if then else if to do multi-way selection. So in this case, we can have something like this. We can use check if it is cold, very cold. If it is very cold, then we do where it cold. Else if it is chilly, else if it is chilly, then we say wear a light jacket. Else if it is windy, then you wear a windbreaker. Else if it is hot, you wear no jacket. So basically, these are mutually exclusive. So you can do only one thing. Notice the minute you hit a condition that is true, the rest of the else if are ignored. So let's say it's chilly. If it's chilly, you just wear a light jacket and you're done. You don't check anymore if it is windy, right? So when you hit a condition, you don't check the other possibilities. So the order is important, right? So you want to put if you want to make sure that if it's chilly to wear a light jacket, you don't want to check the windy condition before the chilly condition. Because if you move this one before the chilly, then what's going to happen if it's chilly and windy, the person may wear a windbreaker instead of wearing a light jacket. So the order is important. It's important to list them in the right order. This is, you can see that also in the code. If you look in here in the code, the order is important. All right, we start with value less than 60 to get the F. Then you go to the D. Then you go to the C. Then you go to the B. And finally you go to the A. So the order is important. It has to be either from F to A or from A to F. You cannot put them in random fashion. In other words, you cannot just put the grade for A, then the grade for F, then the grade. It has to be in order. F, D, C, B, A, or A, B, C, D, F. It has to be in an order fashion, right? It's very important because they are mutually exclusive. So each of the series of conditions in the if then else if is tested in sequence. When the condition is true, the remaining conditions are ignored. That's why the order is important, right? The order is very important. What's happening? Let me give you an example in here, right? If you check for this condition first, right? If you do this one, you move it to the top, right? Move it at the beginning. If DBL average less than 90, right? Then the person will get a B, right? And then he's done. But this won't be correct. Why? Because what does it mean less than 90? I mean, you can get a grade of 50. 50 is less than 90, but 50 is an F, it's not a B. So everybody's gonna get a B or maybe A at the end, right? So the order is important. You have to check first for the lowest values, which is F, then the D, then the C. So the order is important because once a condition is hit, the rest are ignored. So if DBL average is less than 60, it's going to give you an F, and then it will go continue with the output. It will not check for C, D, C, B, or A. So the order is important. When the condition is true, the remaining conditions are ignored. The order of the condition is vital. Wrong order can result in wrong decision, called a logical error, right? For example, what if it's chilly and windy, all right? If it's chilly and windy and you test it for windy first, so if windy is tested before chilly, then you go out with a windbreaker when you need a jacket. So the order is important. If you put this condition before the chilly condition, then if it is windy and chilly, you're going to end up with a windbreaker when you need a jacket. So the order is important. This is general format. You check an expression, right? If the expression is true, you do the then clause, right? You do the first one. If it is not true, you check the second expression using else if. If it's true, you do the second statement. And you can repeat as many else if as you want. You can put as many else if as you like. At the end, you do a trailing else. If none of the else if matches, you do the trailing else, which is the last statement. This construction is like a chain of if then else. So like you have one if then else statement inside another if else statement, etc. The else part of one statement is linked to the if part of another. That's why you call it else if. So it's like chaining, putting an if statement inside another if statement inside another if statement. You're chaining the else and if together. Right, here's a flow chart that show basically how this works. You check if it is very cold. If it is very cold, then you would say wear a jacket. Notice after a condition is executed, you exit. You go in here to this pass, you follow it down, and you're done. You exit, right? So if it's chilly, you wear a jacket and you exit. If it is windy, you wear a windbreaker and you exit. So that's what it is. This is a flow chart, which help basically show the graphically show the logic of your code. Here's an example, a very common example. And here, the example we just did is to get the letter grade, right? You check if the average is less than 60. If it is less than 60, the grade will be F. If it is not less than 60, right? So you go to the else. When it's not less than 60, it means the opposite is true. That means it is greater or equal to 70. Right? Some people is gonna do it like this, right? Some people is gonna try to do it like. Some people are gonna try to write it like this. We're gonna probably maybe put in here F DBL average less than 60. Then maybe STR grade equal F. Some people will try to do it like this, else F. And then we put two conditions, may say DBL average greater or equal to 70 and DBL average less than 70. Then, and then we put in here SCR grade equal to D. So some people may do it like this, right? Which is perfectly valid. There's nothing wrong with that, all right? If it is greater or equal to 70 and less than 70, right? Greater or equal to 60, sorry. If it is between 60 and 70, greater or equal to 60 and less than 70, it's a D, right? So there's nothing wrong with that. But this condition, the first condition is not really needed. Okay, you don't need that, right? Because this condition is false, right? If this is not true, when you go to the else, right? When you go to the else, the fact that you are in the else clause, it means that this is false, right? This is false means the opposite of it true. The opposite of less than 60 is greater or equal to 60. So this one is implied. This one is implied, okay, from the previous one. Since it is implied, you don't really need it. You can take it out. So it's not needed. You can take it out. And this one definitely you can take it out. So you can just do this one. Because from the fact that you are in the else F, this is implied. And then you check on the upper bound. And this will give you that. So that's why it is always redundant. So you don't want to do something redundant. So this is, you can take it out because you already know that this condition is true from the fact that you are in the else F. Okay, same thing. If you go to the else F in here, right? Okay, this condition is false that you are in here. This condition is false, which is you get an implied thing, which is DBL average greater or equal to 70, and DBL average less than 80. Then you have SCR grade is C. Again, this thing is implied, right? The fact that you are in here, it means that this condition is opposite, is true. The opposite of this condition is true. The opposite of this condition is you reverse this one instead of less than, it will become greater or equal, right? So this is implied. Because it's implied, you don't need it, you can take it out. So you can do that. All right. So this is why the code look like this. Right. This is why the code look in here. If it is look like this, so if the DBL average is less than 60, it's an F. Else, if it is less than 70, it's a D. Else, if it is less than 80, it's a C. So the lower limit you don't put because it's implied from the previous condition, right? But the order is important, right? You check first for the F, then the D, then the C, then the B, then the A, all right? It has to be in order, either from F to A or from A to F. Otherwise, you're not gonna get the right answer. So the question here, does the order of these conditions matter? Of course it does. If you don't put them in right order, you're gonna get the wrong result. What happens if we reverse the order, right? So if we test this one first, is average is less than 100, you get an A, right? But everything is less than 100, right? So even if student gets scored 50 or 60, they're gonna get an A, right? Because 50 is less than 100. So everybody will get an A. So what would happen if you reverse the order? Everybody will get an A, right? You don't want that. So you have to put it in that right order, right? Now you can reverse the order if you like, but you have to reverse the condition, right? You can, if you like, reverse order, but this is how you would do it, right? If you're going to reverse the order, if you're going to start checking for A's first, you reverse this condition, right? If it is, and instead of saying less or equal to 100, oh well, okay, actually, maybe we can. Let's start from the. So this one. Okay, if you're going to reverse the condition, then you have the condition. Instead of saying less than, you say greater or equal. The opposite of less is greater or equal. So we can do it just starting with the A's, right? So we can do in here if DBL average, all right? And you reverse the condition, greater or equal to 90, right? So instead of saying less than 90, right? Instead of using less than, use the opposite, greater or equal. Then you can say STR grade is equal to A, right? Else if, okay, again, you can, if you like, put in here DBL average greater or equal to 80 and DBL average less than 90. And then puts STR grade is a B, right? but this one is implied. This is implied. The fact that you're in the else if, it means that the opposite of this condition is true. The opposite of this condition, dBl average greater or equal to 90, is dBl average less than 90. So this is implied. So this and you can take it out, right? Else if, and you can do it this way. You can go from A to F, dBl average greater or equal to 70. Then you don't have to say and dBl average less than 80, little equal to, sorry, equal to less than 80, because this is implied, right? Then you can say str grade equal to C, and you can keep on going, right? So you can go from A to F if you like, right? Or go from F to A, but it has to be an order: A, B, C, D, E, D, F, right? And similarly with the other one, right? How about doing this thing, right? What's the difference between this one and the other one, right? This one, if you look at this one, you have multiple if statement, right? Not just one, multiple. You have if and if, right? And then you have if and if and if. If you look at the other one from the previous slide, you have a single if statement. If, else if, else if, else if. The difference is this: these conditions are mutually exclusive. You can get only one true, only. So one of them is going to execute only. They are mutually exclusive. So that means, what does it mean mutually exclusive? You can get only one grade. That's what it means. I mean, you can get only one grade. You cannot get two grades, right? The other one, on the other hand, is not mutually exclusive, right? So you can get the first one, and then you can get the second one, and the third one. They're not mutually exclusive. And this is going to make a big difference, right? Because it's going to give you incorrect result. You may think it's going to give you correct result, but it's not. Let's do an example. Let's say what it would be assigned for the grade if the average was to average 65. Let's say the average 65. What grade would the student get? All right, you check. Is 65 less than 60? It is not, right? So you do the next one. Is average less than 70? Yes, 65 is less than 70. This is going to set the grade to D. All right, so you say it's great, it's okay, it's working all right. You may say that, right? But we haven't finished yet, right? Because these options are not mutually exclusive, it's going to continue. So it's going to go to the next one. Now, is DBL average is less than 80? 65, guess what? Is less than 80. So his grade get bumped up to a C. Now he gets a C, right? Okay, and it get better, right? Next one, it goes, is the average less than 90, right? 65 is less than 90. So his grade get bumped to a B. And then you check it again. Is 65 less than 100? Yes, it is. You get an A. Basically, everybody's going to get an A, right? So basically, this doesn't work. You have to use a mutually exclusive structure, right? The rule is this: if you can get only one letter grade, you have to use a mutually exclusive structure. Not multiple if and if, but a single if else if statement. You have to use if else if else if else if. So if else if or if else are for mutually exclusive structure. Non-mutually exclusive structure, you use say if and, right? We're going to talk about other control today. All right, new control. We're going to talk about it today. You probably, I'm sure everybody's familiar with. One of them is called maybe radio button. Maybe you can have a region, and you can say in here Western, East region, Southern region, and Northern region. That's called the radio button. That means you can select only one option. You cannot do two of them. So if you select, so you can select maybe probably the west region, right? If you try to select the northern region, let's say you select the northern region, it's going to deselect the western region, right? So they're mutually exclusive. So this is mutually exclusive. And because they are mutually exclusive, you process them with if else if. Right? Because they're mutually exclusive. You have to process them with if else if. The other one we're gonna talk about today, another new control we're gonna talk about is we're gonna talk about maybe check boxes. Okay, maybe you can put in here cream, sugar, chocolate, and then you can check they're not mutually exclusive. You can check that you want cream and sugar, right? So they're not mutually exclusive. In this case, they're not mutually exclusive. And whenever you have non-mutually exclusive structure, you process with multiple if and if. So when they're not mutually exclusive, you use if and if. You don't use if else if, right? If they're mutually exclusive, you use if else if. All right. We're gonna talk about them when we write programs that use radio button and check boxes. We're gonna process the logic for radio button with if else if statement. And when you use checkboxes, we're going to process the logic that use checkboxes with if and multiple if and if structure. So this is important things to remember, right? So the important thing here you would see if you look at this example, these are mutually exclusive. That means you can get only one grade, either A, B, C, D, or F, only one. You cannot get two grades. So they're mutually exclusive, use if, else, if. And we can use that for radio buttons. And when we get to checkboxes, we're going to use these because checkboxes are not mutually exclusive. So we use multiple if and if structures, right? Sometimes you may want to add a trailing else, right? So maybe a student may have an average, let's say 110, right? Maybe we should allow it because maybe the student is doing some extra credit and he was able to get more than 100%, all right? So maybe we should allow it and treat it as an A. But also, maybe when I think about it, maybe it's an error in the input that the student, no matter how good he does, should not get more than 100%, right? So in this case, if we want, we can put a trailing else. Let's say invalid score. So if basically he get more than 100, because if you look in here, the condition, the previous condition, DBL average less or equal to 100, right? If you get to the else clause, it means this is not true. That means the opposite of true. That means the average is greater than 100. So if you go to here, it implies, this is implied, that the average is greater than 100, then you say invalid score. So you can do it. This is called the trailing else. So you can do that. The other way you can do is you can do nested if statement. You can put one if statement inside another if statement. Okay. Let's do an example on this one to see why you would need that. An if statement within an if statement is called a nested if statement. Any type of statement may be used inside the then, else, or else if clause, right? This includes other if statement. if statement within if statement, that means if statement inside another if statement, create what we call nested if statement, which the effect of it is combining condition together, right? So let me go ahead and look at this one. Um, if you have in here, if you say if condition 1, then, and you put another if statement, if condition 2, then the effect of putting these two inside this if statement inside of a statement is to combine the two conditions together. These two conditions now, condition 1 and condition 2, get combined to create condition 1 and condition 2. That means both condition has to be true. So it creates a combining effect, right? So this is more like equivalent to saying condition 1 and condition 2. So you can have that, all right? So the effect is to combine the two. Let's go and look at an example to see how this can be used, all right? Right. Let's say that we have a bank application, right? The customer may qualify for a loan, right? If he meet one of these two conditions, right? Either earn $30,000 per year or more, okay, and have worked on his or her job for more than 2 years, right? All right. Or he have worked at his job for more than 5 years. So if he's been on the job more than 5 years, he doesn't need the minimum salary requirement, right? But if he have been only 2 years on the job, 2 or more years, then he need to have at least $30,000 thing. So this way, one way you can look at this thing is to use a nested if statement, right? So in here, right? So we can say in here, 30,000 per year or more, and more than 2 years. Okay, right? Okay, so we can use an if statement in here. You can say, let's say in here, and you can say in here if DBL salary is 30,000 or more, right? 30,000 or more, that means greater or equal to 30,000. Then to qualify, that means he also need to have been on the job for more than 2 years, right? So in here, he have to be on the job. So if he earns $30,000 or more and have worked in his or her current job for more than 2 years, more that mean greater than, more than 2 years, that mean end year is greater than 2. The effect of putting this if statement inside of if statement is to combine the two conditions with an and. So salary is greater or equal to 30,000 and the year on the job is more than 2. Both of them are combined, and what this gives you is gonna basically say that he qualifies. We can say maybe LBL output that tax qualifies. He qualifies for the loan because he's been on the he earned more than 30,000 per year salary, and he have more than 2 years been on the job. However, if he's been less than 2 years on the job, right, 2 year or less, right, then he doesn't meet the criteria because he have to be at least 2 years in the job. So you're saying here LBL output dot text does not qualify. Right? Now, every if else need to have and if. So you need to have an and if in here. This would be the nested if statement. They go together, right? Now this one need to have another else in here. So let's go ahead and put an else in for this one. All right, so we have the else for this one. So if he doesn't have a salary that is more than 30,000, that means his salary going to the else, there's an implied salary less than 30,000, right? Less than 30,000. So if the salary is less than 30,000, can he still qualify? Well, let's see. If the salary is less than 30,000, so if he have worked for this job for more than 5 years, so more than 5 years, he can still qualify, right? But he have to be more than 5 years on the job. So yeah, so he can still qualify. So we're gonna go and check for that condition. So we put another nested if statement. We say if int years is more, that means greater than 5. So if it's greater than 5, then we're gonna say in here LBL output that text qualifies. Else, if he's not been more than 5, then he doesn't qualify because his salary is less than 30,000. So we're saying here else LBL output that tax. We can say in here does not qualify. And then we have an and if in here. So okay, we need two and if in here. We need and if for this one. Right. Will create this nested if statement, and you have another and if for the outer one. Right. So this is, you can see in here the outer have also and if. So we have in here, you can see it, the importance of indentation. By indenting the code, you can see that you have a nested if statement in here. If you put everything to the left margin, you're not gonna see the structures. But this way you can easily see the structure, the logic in here where you do that, and this would help. Now I could have done this one a little bit differently, right? I could have done it using logical operator, which we'll talk about it in a minute, but I could have wrote this thing. I could have done it this way. I could have said here if DBL salary greater or equal 30,000, and int is greater than 2, then I can say qualifies. Actually, I could have done this thing, and then I could have said or int is greater than 5, then qualifies. LBL output that text equal qualifies. Else LBL output that tax equal does not qualify. And if. So I could have done it this way without nested if statement, right? I could have done it without nested if statement, right? But you have to use what we call, you have to use these operators. These are called the AND operator and the OR operator. These are called logical operator. You have to use these things to be able to use them. So that means if you have salary more than 30,000 and years more than 2, or if his number of years is more than 5, then he qualifies, right? Else he doesn't qualify. So in this case, doing it this way is easier, right? Using logical operator, right? But you could have done it also using nested if statement like this, right? So which one is better depending on what you're doing, right? If you're doing something like this example, it's better to use logical operator and or. It makes it simpler, right? But if you're doing something where you have too many possible combinations, you need to try too many different combinations. Maybe there are 3 runners running for a race, and you want to find who is going to come on the first place, second place, and third place, because you have too many different combinations. Who can come first, who can come second, who can come third. A nested if statement will exhaust all possibilities, so it will work nicely, because this way you make sure that you haven't forgot anything, right? Because it's going to try all possibilities that you can have. So, but if you have something like this one, probably using logical operator and an or will work nicer than the other one. Let's go ahead and continue with this lecture. Let's see how this is how he implemented this thing. Right, this is basically the idea. Now, this logic you're using is not the same as he described in the text. In the text he described, he'd say earn 30,000 per year or more, right? So it should be should be greater or equal. It should not be greater, right? If you want to say greater, he should say earn more than 30,000. So he phrased it incorrectly in the text. So this doesn't match this one, right? Because this one he's saying more than 30,000, right? It should be greater or equal, not greater, right? And so if it is greater or equal to 30,000, then you have the nested if statement. If it is more than 2 years, then applicant qualifies. Else applicant does not qualify, right? If on the other hand, he doesn't earn more than 30,000, that means the opposite is true. That means he earn less or equal to 30,000. Then you check if he's been more than 2 years. If it's been more than 5 years. If it's been more than 5 years, he qualifies. If he hasn't, he doesn't qualify. Okay, anyone have any questions? This is the flow chart of it, right? So basically check in here the first condition, if the salary more than 30,000. If it is more than 30,000, you check if he's been more than 2 years. If he's been more than 2 years, then he qualifies, right? If not, he doesn't qualify. If not more than 30,000, then he's been more than 5 years, he qualifies. Right, so this is nested if statement. So this is the outer if statement, and these are the inner if statement. So this is the structure. Okay, now you can have solved this problem differently using the and or operator. These are called logical operators. So let's talk about these. Right, they are basically 4 logical operators. 3 of them are binary operators. This is the and, the or, the exclusive or. These are binary operator. The not operator is a unary operator. That means it requires 1 operand, right? The other operator requires 2 operands. The and operator, the or operator, the exclusive or operator require 2 operands. Now the and operator will combine the 2 conditions, giving you true only if both condition is true, right? If any one of the condition is false, you're gonna get false, right? Okay, we'll see the truth table for it, so you'll see it in a minute, right? The or operator will give you true if at least one condition is true. So if one condition is true or 2 conditions are true, you're gonna get true. If if both conditions are false, you're gonna get false, right? This is not the same as or we use in English, right? Right. So, for example, um, you can say that I want to go to the movie or the theater, right? You cannot be at two places at the same time in regular English. That means you're going to one or the other. You cannot have both of them true at the same time. So if both of them are true at the same time, it is false because it cannot happen. You cannot be in two places at the same time. But this one will give you true. If both conditions are true, you're going to get true. The one we use in English is more like the exclusive OR. The one we use in exclusive OR. Exclusive OR, we're going to give you true if the condition are of opposite sides. That means one is true and one is false, then you're going to get true. If they are of the same state, both of them are true or both of them are false, you're going to get false. So, and the NOT operator is going to negate the condition. If it is true, it's going to become false. If it is false, it's going to become true. So it reverses logical value. Right. Let's see how this is work. Right. Here we have in here the OR condition, the AND operator. The AND operator, it evaluates two expressions, right? Expression 1 and expression 2. The only time you're gonna get the value true is if both expression is true. So if expression 1 is true and expression 2 is true, you're gonna get true for expression 1 and expression 2. Note the other three condition will give you false. Right? So the only time you're gonna get true if both expressions are true. Now, the AND operator are very useful in checking, do range checking, right? Let me show you what it is. And this is very important in programming. You're gonna do range checking, right? What does it mean, range checking? All right, you might make sure that the value is between two bounds, a lower limit and an upper limit. You may have maybe a line in here, okay? And you have two value in here. Let's call it in here, lower bound, and you have an upper bound. Right? And you want to check if a value is within a range, right? So you want to see if the value is within this range, between lower and upper, including lower and upper. And see that, make sure that it is in this bound. To do that, this is called in-range checking. And this is very common in computer science. You have to check a value in range. For example, you may say, all right, to qualifies, you must be between the age of, 10 and 15. If you are outside this range, you cannot be in this thing. This is for kids in that age range. So you have to check the age range. You can use this checking. You use in-range checking, you use AND to do in-range checking. The way you do it is, it's like a cookbook formula. I'm going to give you lots of cookbook formulas in this class, and you need to maybe mark them down to make sure you use them. The cookbook formula in here, to check if it is in range, you would say in here, if maybe variable, let's say if value, let's call it, is greater or equal to lower, and value less or equal to upper. Then you can say in here message box. It doesn't have to be message box. It can be maybe an output or a text box that show in range or inside range. Right? So you can do that. You can check it in here. Else you can do in here message box that show, and you can say not inside the range. This is very important. You're gonna see in chapter 4 assignment, you're gonna see lots of exercises gonna give you in here input validation, and it's gonna ask you for input. Make sure that the object weight is between 10 and 20, or that the object does not weigh more than 30, or it's between this value and this value. This is in-range checking. How you check it is by saying value greater or equal to lower limit and value is equal to upper limit. For example, if you want to check if a value is between 20 and 30, you can say if value greater or equal to 20 and value less or equal to 20. And you can check if it is within the range or not. Right? It's called in-range checking. You do in-range checking using the AND operator. Always you check for in-range using the AND operator. So let's say one use of it to check for inside the range. And this is basically what this does. Okay, so the AND operator is gonna give you true only if both conditions are true. If any one of them is false, you're gonna get false. All right. Now, from that fact, you would see in here something in here. You would look in here that notice if you have false in here, right? If the first expression is false, right? Then regardless of what expression 2 says, you're going to get false, right? So in other words, false ended with anything is going to give you false, right? So in here, you can, if you like, you can say, false and anything gonna give you false. So it doesn't matter what you have, false and with true, or false and with false, you're gonna get false, right? Because you have that, there's another operator that does what we call short circuit evaluation. All right, what does it mean? All right, is that if the first condition is false, you don't have to evaluate the second expression, because you know the whole thing is going to be false, right? Okay, so if you want to do that, instead of using AND, if you use AND, it's going to still evaluate the second expression, which is going to waste time. If you want to save time, you can say false, and you can say AND also. The AND also, what it does, when you see that the first condition is false, it's not going to evaluate the second expression because it knows it's going to be false. So it evaluates only the first expression. So it can save you time. This is called short circuit evaluation. Let's go ahead and see how this works, right? You don't have to really need that to do all the lab work, but let me explain the concept, right? Short circuit evaluation with the AND also. When using the AND operator, if the first expression is false, then the entire expression will be false. If there's no need to evaluate the second expression, it can be skipped using a method called short circuit evaluation. In Visual Basic, you can use AND also operator to achieve short circuit evaluation. So in a sense, the AND also is like the AND operator, except it does short circuit evaluation. In other words, if the system determine that you don't need to evaluate expression 2, it will not evaluate expression 2, and it will save you this way some time, right? So let's go ahead and look at this thing. I don't have my watch in front of me, but let me see what time is it, because I don't want to go over the time limit. Actually, let me go ahead and get my watch. I want to pause the video for a second. I'll go ahead and get my. Okay, so basically the AND also is like the AND operator, but if the first expression is false, it doesn't evaluate the second expression. Why you need to do that? Here's an example. In this example, we have in here, we're checking if DBLX is greater than 0, and if the DBLX after it's processed by a function called check value is true, then we're do. So what happened in here? This function may do lots of processing. It may look up some data in a database or other things to do checking, and it may take time. It may not be something that you can execute in a little time. So what would happen is you check first if it is greater than 0. If it is not greater than 0, then you don't call the function to do some database checking. So you can save time. This is called short circuit evaluation. In this case, it would make sense to use AND also instead of using AND, because if you use AND, even if DBLX is less than 0, it's still going to call the function and waste some time, right? So that's what it is. So in the following example, assuming that DBL is less than or equal to 0, check value is not called, and the expression is false is displayed. So it does short circuit evaluation in this case. The other one in here we're going to cover is the OR operator. The OR operator are very good to do outside range checking. But you notice in the OR operator, the only time you're going to get false is if both condition is false. This is the only time you're going to get false. If both expression are false, you get the results going to be false. If any one is true or false or true, or true, you're going to get true. So the only time you get false if both expressions are false. Now, this is very useful to check if a value is outside the range. And I want to illustrate that also using the application here, the projector. So in here, this is in range checking. Let's see how outside of range checking look like. So in here, outside range checking, you have basically, again, the scale, and you have in here the lower limit, and you have the upper limit. But in here, what you're checking for value that is less than, not less or equal. So it's very close to lower, but doesn't touch it, or greater or equal, greater than upper. So again, it's very close to upper, but doesn't. So we're looking for this range, outside the range. This is called out of range checking. So when you do out of range checking, you would use basically the OR operator. So we can say in here if, and the condition you would use in here if value less than, lower, or value greater than upper. So if both condition is true, then you would say in here, message box maybe dot show, but you say in here, not inside range. Else, you can say message box inside the range. So you can do that, okay? So you can do for inside the checking and outside the checking using the outside the checking. You can use the OR operator. So again, if you want to check for outside the checking, use the OR operator to do that. Keep in here in mind the saying when you do outside the checking, value is less than lower, okay? When you do inside the checking, value greater or equal, the condition is the opposite, greater or equal to lower, less than lower, opposite condition, right? All right, or value greater than upper, the condition is opposite, value for range, value less or equal to upper, for outside the range, value greater than upper, to use opposite condition. So these are common, you can use this thing. You don't really need to use both of them, right? You can, because they complement each other, right? So the difference between the two is in here is to check if you have valid value, if it is in range, then you put if you want to check for, if you want to use a positive logic, if it is in range, you want to do the processing, then you can use the AND operator to do in range checking. If you like to display the error message first, then you can use out of range checking. So in this case, for this example, the error message will get displayed in the else clause, right? In this example, the error message get displayed in the then clause. So depending on how you're gonna use that. So I like to use myself. I like to use outside range checking. So if we have an error, display an error message, and don't do the processing, else do the processing. I like to do it this way, but some people like to do it that way. So it's a matter of preference. But anyway, this is how you can check for that. Again, the OR operator have a short circuit operator called OR else. As I indicated with the OR operator, the only time you're gonna get false is both of them is false. If you have a true, okay, if the first one is true, then regardless what the second expression is, the whole thing gonna be true. So if you have a true ORed with false is true, true ORed with true is true. So because of that, you can use short circuit evaluation. You can use OR else. If you use OR else, then the second expression will not be evaluated if the first expression is true. Let's look at that. So short circuit evaluation with the OR else, when using the OR operator, if the first expression is true, then the entire expression will be true. If there is no need to evaluate the second expression, it can be skipped using short circuit evaluation with the OR else operator. So OR else is like the OR operator, except it does short circuit evaluation, right? Which can be useful when you're calling a function that may waste some times, and you want to check to make sure that you really need to call the function or not. Here's an example in here. In here, you check if dBLX equal to 0, right? So if dBLX equal to 0, right, then you don't really need to call the check value, because what's going to happen, dBLX equals 0 is true. True OR with anything is true, so you don't need to call this one. If you use OR, it will call the check value, but you use OR else, the check value will not be called, right? So in the following example, if dBL is equal to 0, check value is not called, and expression is true is displayed. So it just it can save processing time doing it this way. Now, exclusive OR is similar to the OR we use in English, basically. That mean you will get true only if the expression are of opposite states, right? So if you have true exclusive OR false, or false exclusive OR true, you're gonna get true, right? If the two expressions are of the same state, you're gonna get false. If both of them are false or both of them are true, you're gonna get false. So it's the only time you're gonna get true if they're of opposite state. Again, the example of going to the movie theater or going to a theater, you can be in one place only. You cannot have both of them true. So if both of them are true, you're gonna get false. Also, if both of them are false, you're gonna get false. So the only time you get true if both are they are of the opposite state. This will get true. The not operator is will negate the expression. If the expression is true, it's gonna give you true. It's gonna give you false. If it is false, it's gonna give you true. So if the expression is true, you're gonna get false. If it is false, you're gonna get true. So it negates it. All right. So so if you check in here, if not in temperature greater than 100, that means if it is less or equal to 100, that's what it means. If it is less or equal to 100, that's what it means. So so it's kind of what it does. It's the only Boolean operator or logical operator that is a unary. That means it works only on one operand. So there's only one expression. You don't have to do expression like the and the or operators. This is ranges. This is what I told you. Basically, you can use the AND operator to check if value are within range. The AND operator is best for checking if a value is inside the range. For example, you can say if int x greater or equal to 20 and int x less than 40. That's between 20 and 40. right? For inside range checking, right? This is they can use the OR operator is best for checking if value is outside the range of numbers. For example, you can check this one if int x is less than 20 or int x greater than 40, right? So you can use that. Notice that when you use and, you use the condition is you use the operator greater or equal, and here it become less, the opposite with the or, and here less or equal when you use the or become greater. So use the opposite relational operator basically. When you evaluate expression that have multiple logical operator, the precedence is as follow. You do the NOT operator first, then you do the AND operator, then the OR operator, then the exclusive OR operator. So you do them in that order. Right. You can use parentheses to override this precedence if you like. So look at this one. You do the AND operator first. First, you do the relational operator. Relational operator comes before logical operator. So you compare if x is less than 0, it's going to give you true or false. You compare y greater than 100, it's going to give you true or false. Then you combine them with an AND, right? You do the AND, and then you do this one, and then you do the AND, then you do the OR. The AND comes before the OR. If you want to do the OR before the AND, you can put that in parentheses. If you use parentheses, then the OR get performed before the AND. Right, we'll do one example, and then we'll call it off. Actually, it's almost about time in here. Here's an example. I'll let you practice with that. And here, A is equal to 5, B is equal to 7, X is equal 100, Y equal to 30. First, you do arithmetic operator. Okay, let me go ahead and write it down anyway. And it'll keep you a little bit over the time. So in here we have if X greater than 8 times 100 times 10 and Y less than B plus 20. Right, so we're evaluating this expression. Let me go ahead and let's put in here the value. In here we have A is equal to 5, B is equal to 7, X is equal to 100, and Y is equal to 30. Right, so I'm gonna go ahead and switch to the projector. So that's what we have, right? So in here we check in here. First, you perform arithmetic operator first. So you're gonna perform this one first, the multiplication, and then this is second, the addition. So you do that. 8 times 10 is 50. B plus 20 is 27. And then you do a relational operator left to right. So this is gonna be a performed third. So you check, is X greater than 50? 100 is greater than 50, this is true. And then you perform this one's fourth. All right, again, you check, is Y less than 27? Y is 30, it's not less than 27, this is false. Okay, then you perform lastly, you perform the AND, this is 5. So you do in here, true and it was false is going to be false. So the whole expression is going to give you false value, right? So you can use that. Basically, arithmetic operator are performed first, then relational operator, finally logical operator. This will give you the result. And here, if you check this one, is going to give you the result of false. You don't have to use parentheses, but if you want to clarify the meaning, you can use parentheses. This is easier to read and clear to read what you're trying to do than the first one. All right, and we will continue on Thursday with section 4.7. All right, that's all what I have for today. I'm going to go ahead and stop the recording. If you have any question, you can let me know after I stop the recording.